Alright, so here is a second problem from Leetcode. This one is interesting too, so let's read it together. So given a string S containing just the characters open parenthesis, close parenthesis, open bracket, close bracket, and open whatever that is, and closed whatever the corresponding element is, determine if the input string is valid. And then it defines rules that we all understand very instinctively, which is open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. Yes, so those are the exhaustive rules of how bracket work. So let's say we have that. Is that valid? Yes, it is. Let's say we have this. Is it valid? No, it is not, because some parentheses are not closed. That is the opposite. And finally, you have mismatch like this. So let's think about it conceptually. How do we solve that? You can start doing some interesting stuff like, oh, maybe I set up some kind of a counter that will increase each time I meet a parenthesis. Maybe I have a counter open parenthesis that is equal to 0. I have a corresponding counter for brackets and such. Like, that's something you can think about, and maybe you're gonna think, hey, I can solve it like that. This is not very straightforward, and you will have some trouble checking mismatch parentheses like this. Like, you can have a perfectly fine string like this, perfectly fine by the logic of this algorithm, where you have a counter that is increased each time you meet a parenthesis that is open, and then you decrease it when you meet a parenthesis that is closed. But you will not catch the fact that this is mismatched, okay? So counters are not the way to go here. We're going to use something else. And that something else is a stack. Why is the stack so useful in that example? Is because the stack not only will allow us to see if every single parenthesis that is open is closed, it will also tell us if we encounter a closed parenthesis we were not expecting. So let me explain myself. Let's take this example, because I think this might be the most complex we can meet in terms of mismatch. No, actually it's the most simple. Anyway, it's a good representation of what is a mismatched parenthesis string. So you have a stack, and each time you encounter a parenthesis or a bracket or whatever that is open, you add it to the stack. So this is an open parenthesis. Then you encounter this open bracket. You add it to the bracket. And then what do you do when you encounter something closed? Then you look at the top of your stack, and what do you expect? You expect that right before you made the open version of it. So you're gonna expect to meet an open parenthesis if you have a closed parenthesis in your string. Here is not the case, so we can then return false. This logic also allows to keep track of the number of parentheses and brackets and symbols. Why? Because you have, let's say this, one is not closed. What's going to happen on the stack is very simple. This is going to happen. I encounter the first one, we add it. I encounter the second one, we add it. The third one, we add it. And then, how can we keep track that something is properly closed? Well, we check if we met the corresponding symbol. It is the case. We were expecting an open parenthesis because we met a closed parenthesis. And then we pop it. We just pop it from the stack. And following that logic, we will then see that, oh, I expect another open parenthesis. Perfect. I pop it. and then there is nothing else, I check my stack. If my stack is not empty, then I return false. If there was another parenthesis that was closed, then I would pop that, I would remove it, then I would check my stack, and that stack is empty. Perfect. All right, so in summary, we're gonna make a stack that keeps track of all of the open stuff, and when we encounter something closed, we will check if the top element of the stack is the corresponding open symbol. That's how you solve this. Alright, so let's code it up in Leetcode. So first we're going to implement a stack. The easiest way to do that in Python is simply to use an array. Then we're going to iterate over the string that we're given. So for a character in the string, we're going to split in two different cases. So first, if it's an open kind of character, so parenthesis, bracket, or whatever. So if C in those possibilities, then we're going to simply append it to the stack, push it onto the stack if you will. So then you would simply do stack dot append C. Else, if it's let's say an open parenthesis, a closed parenthesis, sorry, what do we expect? We want the top element of the stack to be an open parenthesis, if you remember the logic explained before. So in order to do that, we're going to say, oh, if we fail to meet that condition, we're going to return right away false. So if stack.pop, so popping will remove the top element of the stack and return it at the same time. Stack.pop is not equal to an open parenthesis, then if there you go, then what we're gonna do, we're gonna return false. There is an edge case that we have to think about. What if the stack is empty? So if the stack is empty, that's going to crash because we are not going to be able to pop for anything. So let's add a condition before checking for that condition with implying a pop that says, oh, by the way, if the stack is empty, just return false. So if the length of the stack is equal to 0, or the pop of the stack doesn't yield a symbol that is coherent, return false. We're going to repeat that logic for every single, that is not what I wanted to do, there you go, every single character, there you go. So we have to take into account those characters as well. And finally those characters. Okay. Because this is exactly the same logic. And finally, when we are done iterating every single character in the string, can we return true? Not really. We cannot return true right away, because what if there is still an element on the stack? It means that an open parenthesis or bracket or whatever was never closed. So we expect the stack to be empty. So let's return that the length of the stack is 0 and see if it evaluates to false or true. Let's see if that compiles. Yes, it does compile perfectly. And just for the sake of it, yeah, it seems to work pretty well.